So here we go. The first triangle over here, we have H, we have X, and we have 12 meters. And let's call this triangle A. Okay. We want to use this triangle to find X and H. And we got 3D trigonometry. Our objective for this, just to go back again, is to find X, H, Y, and Z. And so this over here will be X, and this here will be H, and this would be 12 meters, and I'm going to call this triangle number A. I'm also going to call this triangle B over here, and I'm going to call this, whatever answer I get is H over here and Y, and 60 degrees. Now I want to find the value of X, H, Y, and Z. I also know that this is 30 degrees. Using trigonometry, I can see that this is my adjacent side. And I can also see that this over here is my opposite. Because if the angle's over there, that becomes the opposite, and that becomes the adjacent. And so if I take cos, for example, cos of 30 degrees, it will equal x over 12. That'll become 12 cos 30 degrees. And I'm going to put that on a calculator. Make sure your calculator is in degrees mode because we have 30 degrees and not radians. There must be a D at the top of your calculator, not R. And then you've got 12 cos 30, which would be 10.39. So that's 10.39. And it's going to be meters. Okay. For this. Now, from here, what we have is the following. So we have H, Y, which we can then find, but we need H first. All right, so let's go back here again. We've got X, we can find H, and we can use sine, because it's the opposite. So sine of 30 degrees will equal H over 12. And so 12 sine 30 equals H. And so 12 times sine 30 will be 6. And so this will be 6 meters for this. So H is equal to 6 meters, and X is equal to 10.39. Now I know this length over here. I do the same thing. I have my opposite, and I have my adjacent, so I got to use tan. And so tan 60 degrees will equal 6 over y. And so y will equal 6 over tan 60 degrees. And so y equals 6 divided by tan 60 degrees. We put that on a calculator. And that comes to 3.46. And so y is now equal to 3.46. Which takes us to our third triangle over here. This length is 3.46. This is 120 degrees. And this is 10.39. We want to find this opposite length Z. I could call this A, B, C. Let's say I call this A, B, and C. Then this would be equal to small c. This would equal to small b. And this would equal to A. And so therefore, A squared will equal B squared plus C squared minus 2BC cos angle A. And so A squared will equal B squared, which will be 10.39 squared plus C squared, which is going to be 3.46 squared minus 2 times 10.39 times 3.46 cos 120 degrees. And so we put all of that on a calculator. All of that on a calculator. And that'll come to, so 10.39 squared plus 3.46 squared minus 2 times 10.39 bracket 3.46. I'm going to put it in one go, but be careful. The last three, remember, are multiplied together into one term. Then you have another term, and then you have actually three terms. So make sure the last three have no spaces or pluses or minuses, only multiply in between. That comes to 155.87. And if I square root it, my final answer for A, which would be equal to Z, so square root, so press equals, press square root, and then press answer. And you'll get your answer 12.48. 12.48, which will equal the A, which is my Z value. And so that's 12.48. Alright, so 12.48 over here, 10.39, 3.46, and 6 meters. We have used trigonometry, cos, trigonometry, cos, trigonometry, cosine rule, cos rule, to find all the missing parts using this.